So good morning, everybody. Welcome to the North Carolina GIS Conference for 2019. I know it's early. I hope you've had some caffeine and some sugar to kind of get you going. I appreciate you coming in this early and to hear me talk. I know that's the top on everybody's list of things to do. So good to be here. My name is Trip Corbin. I am the CEO of EGIS Associates. I'm also a ERISA past president. I've got about 20 plus years, well, now it's closer to 25, heading into 30 plus years in surveying, mapping, and GIS. I actually started out as a land surveyor working with my dad, who was a licensed surveyor and engineer down in Georgia. So I've had the opportunity to work in a lot of different environments and with a lot of different data types. I've gone out and done a lot of field data collection, using everything from chains and transits all the way up to modern GPS, total stations, and all that kind of good stuff. So I've written 2 books on ArcGIS Pro. Anyway, I got a bunch of certifications and all that. So that's me in a nutshell. So what I want to talk about this morning is your data ready for 3D? So just a quick question, how many of y'all are working in 3D using ArcScene, ArcGlobe, ArcPro, Revit, or any of these other applications up there? So we got one person. How many of y'all have thought it would be at least cool to get into some 3D stuff? Okay, good. That's what I was hoping to see. Most of y'all doing that. And that's good, because as things are changing, as we are getting more capabilities and we're densifying populations and all that, the need to get into 3D is increasing. And that's what we want to talk about. Why do we need to go 3D? Why do we get out of our traditional 2D environment that we've been working primarily in GIS and expand into that 3D realm? And then we'll talk a little bit about some of the challenges we have moving into 3D. What's out there that's really an impediment to moving up into some of the neat things we can do and the vital things we can do with 3D. And then we'll talk a little bit about, well, if I want to go 3D, what types of data can I use? How do I store it in 3D and that kind of thing? So just kind of a primer on getting into that environment as we are moving in that direction. So why do we need to go 3D? Well, I just mentioned a minute ago that we're having densified populations. Our urban areas are growing, expanding. We're getting greater population concentrations, and with that is bringing an increase in supporting infrastructure, right? You go and you look at what's buried under the ground now. We've got, the traditional sewer lines and water lines. We've also got natural gas lines. We've got stormwater infrastructure. Some places have steam piping underground. And then, of course, we now got fiber and electric, telco, all running underground. And while people can accept, oh, I'm sorry, we have a water main break, you're going to be without water for a couple hours, they go, yeah, okay, fine, I can deal for that. I'll go buy some bottled water at the grocery store or whatever. Don't you dare cut somebody's internet connection. You do that and, oh my God, you're going to have a bunch of screaming people. Oh my, I can't Facebook. Oh my God, I can't watch my YouTube, right? We don't want that, right? We need to be able to track where this stuff is and do so in an accurate manner. And you just can't do that well in a 2D environment. We need to know where these features are so that we don't cut somebody's internet connection. We don't cut a gas main, because that's all kinds of trouble, right? We need to know where these things are at, because these are critical functions. I do joke about the internet, but think about how many different things run off the internet backbone. All of your banking systems are run off that backbone. Your internet TV stuff is run off that backbone. Communication systems, networking, VPNs run off that backbone. You cut that and a lot of people can't work, right? We don't want to see that. Of course, people don't like to be without water. We also see the need to be able to track all of these things from an accounting standpoint. How many of y'all heard of something called GASB 34? Well, so that's Governmental Accounting Standards Board Rule number 34, which deals with asset management. Being able to track the condition of those assets, where they are, and being able to assign accounting values to them so you can depreciate them just like you do any sort of desk, chair, car, all these other things. Well, now we have to, as governments, we have to do that. So that requires us to know where they are, the condition, and how we're maintaining them. Well, in order to do maintenance on them, again, we have to know. If we have to go dig something up, well, where do we dig? Do we dig on this side of the road, that side of the road? Do we go 6 feet down or 18 inches? You know, we need to know these things. So there's increasing regulations on this, such as the GASB 34, and then we have CMOM, some other things that deals with utilities, so that we know where our things are at, so that we can see things in 3D. And of course, as we start planning, this is a shot of something we call Spaghetti Junction in Atlanta. That's where I'm from. Right? So this is on the north side where 285 and 85 meet, and we got bridges crisscrossing over each other, right? So being able to do this kind of design and planning work requires 3D environments to do that with. And of course, we're now able to capture that with things like LiDAR, right? And being able to integrate that in. And so if we're not able to handle 3D in our GIS, then we're not going to be able to make use of all these new technologies, such as LiDAR, working. So that's one of the reasons we want to go 3D, so we don't get things like, you know, somebody's planning building a road and it's right here next to the coast and it's inside the base flood elevation or coastal surge, or we end up after a hurricane, as people over in New Bern here can probably attest, with roads that get destroyed pretty easily. We want to be able to plan for that, and again, being in 3D. Being able to locate where these water mains are. This is actually in Gwinnett County where I live. Where it used to take them like 2.5 to 3 hours to shut off a water main break like this, because they just didn't know where the infrastructure was. They didn't know where the valves were. They didn't know how deep the pipe was to get in there to fix it. So we don't want that kind of thing. And as you know, if we have planners, we don't want to do this. We don't want to permit these two high-rise where there's an existing apartment building down here. Right? So we get 20-story high-rises going next to a 5-story apartment building. That's not good. These people who had a view of the park that was over here now don't. They're not going to be happy. And these are the citizens that are voting, right? We don't want to see that kind of stuff happening. We need to be able to plan for that. And we wouldn't necessarily see these kind of things in a traditional 2D environment. The other thing I always talk about going in 3D is it is cool. There's no doubt about it. It's really cool. And I say don't ever discount the ooh-ah factor. If you go into a city council meeting, county commission meeting, and you take your traditional 2D maps in there, yeah, those are nice, and not this, but if you walk in with something that looks more like this to illustrate your point, it's going to have a lot more impact on it as well. And so when we're thinking 3D, don't just limit it to infrastructure. You can do a lot of 3D displays with other things. So maybe if you're looking at population densities, for example, you could show the population as a 3D shape. You could extrude up. So there you could really see where the greatest concentrations of population are and where the least because you'd have such a disparity in the size or the height of those features, right? So it gives you a whole new way to look at the data that's even more impactful than what we do traditionally. So what are some of the challenges? Well, in the past, if you've been using things like ArcMap, you couldn't visualize data in 3D, right? Or if you had AutoCAD LT or something like that, the software just didn't support visualizations without some sort of extension. So like I said, if you're using ArcMap, you can't. You've got to buy the 3D Analyst extension, which is another $2,500, and use ArcScene or ArcGlobe. So we had some limitations on the ability to do that. And that's slowly going away. We can visualize things now with ArcPro in 3D. So ArcGIS Pro supports native 3D displays without any extra extension. It's just there. So you can extrude, apply city engine facades to things, and do all that right in the core product with ArcPro. So it's going to open up the ability to visualize in 3D to everyone that's on the Esri products. QGIS, I think, has the ability, and if somebody knows better, I'm an Esri guy, so. But QGIS, I think, has the ability to view in 3D now. If you're using AutoCAD Map, or Civil 3D, they've always had the ability to go into 3D environments. So we can certainly now have that ability. The software limitation is disappearing. The next big hurdle is our data 3D? right? So that's always the question. It's not, is it 3D so much, because a lot of it's being collected with GPS or GNSS now, or LiDAR, which is natively 3D, but is it, if it was collected even with 3D, is it correct, right? So if somebody goes out and uses a handheld GPS unit, I'm going to use my phone as the example here, and they're collecting it with this, and oh, that's sun, I can't see my screen, so they do this number, right, to see and collect the data. That, anything you're doing, this is not accurate elevation. If you want that antenna has to be on a pole of a known height, right, to get, at least at a minimum, to get good accurate elevational data. So even if we have some elevational data, it might not be correct. And then if we've gone out and say collected building footprints, then, well, great, we know where it is on the ground of the elevation there, but how tall is the darn thing, right? So we're missing those heights. Or maybe we have, power poles. Again, we don't have the heights necessarily on those. So being able to get that kind of information, right, to get the accuracy levels we need. Now, you'd be surprised at where you can get some of this information. So if you're dealing for example, with building footprints or buildings you're trying to do, at least out of the county's CAMA system, the Computer-Aided Mass Appraisal, they usually at least tell you how many floors are in the building, right? So with that, if you know the number of floors and say the average floor height is 10 feet, so you got 8-foot ceilings and then 2 feet of joist space in between, then at least you could average out or estimate a height on that when you extrude those. Of course, we also have problems with data that's in other systems. If we're in ARC trying to read AutoCAD back in, that can be kind of iffy, and so on. So we've got some challenges there that we have to overcome. Of course, then accuracy, like I was talking about, trying to make sure that we know what we're collecting our data with. So I mentioned the handheld GPS, doing this number is not good, but just understanding the limitations of the equipment. Anybody have any idea how accurate data collection is with, say, a smartphone or a tablet? Yeah, it can be anywhere from 10 feet up to 30 feet, and it doesn't usually really tell you what the accuracy expectation, but that's the horizontal accuracy. With any device, whether it's one of these, whether it's one of these Trimble units, whether it's a survey grade unit, your vertical accuracy is 1.5 to 2 times your horizontal. So if I'm looking at, upwards of 30 feet with one of these, that means your vertical is upwards of 60 feet. So can you really use that in a 3D environment? Not if you're trying to really accomplish anything other than make it look cool. Right? So make sure you understand the limitations of the systems you're using. A lot of folks just assume that, well, it's GPS, it's got to be accurate. It navigates me down the road and it knows what road I'm on. Well, yeah, if you're within 30 feet of the road, it can snap you to the road in your app. It's not that big a deal. But again, if we're going out and trying to locate a sanitary sewer system and we're standing on a manhole, plus or minus 30 feet could put us in the creek or on the other side of the creek, and then you got 60 foot plus or minus, it could have it way up in the air or way deeper than it should be there, which then causes it to flow in directions it's not supposed to. So we need to be aware of that and then make sure we're using proper collection methods. If we are concerned about vertical, put that antenna or that device on a pole. Measure that, what we call the HI, the instrument height, on there, and put that in. The other thing is when we're collecting data from a vertical perspective is just like in horizontal data collection, vertical data collection, we have datums, and they're different datums. So we have the NGVD 29 datum and we have the NAVD 88 vertical datum out there. So you have to make sure when you're going to collect that information that you know which datum you're referencing. I don't know, maybe somebody does know what the average kind of difference of elevation is between those two datums here in North Carolina. Anybody got a clue? Okay. Well, I know in some places it can be upwards of 20 or 30 feet worth of difference. in there. So you need to make sure you know which one of those you're referencing. And then, of course, you also need to remember, am I collecting data on the ellipsoidal height or the geoidal height? Is it just the ellipsoidal model, which is a nice kind of smooth model, that's what we use in most horizontal coordinate systems, or is it a geoidal, which accounts for some of the terrain change by using gravitational models of the Earth, right? And again, they can give us two different elevations, so we need to make sure we know what we're working with. And now we have another wrinkle coming into this in a couple of years, the 2022 datum. It was supposed to be the 2020 datum, but it got pushed out, so that's the 2022 datum, which is a combination horizontal and vertical datum, which means at some point everybody's going to have to project their data over when they redefine all the state planes with this new datum. But it's also, including the vertical, which is nice. It means you pick one datum and you're done. You don't have to get, okay, I'm going to use NAD 83 HARN for my horizontal, and then NAVD 88 for my vertical, and because most people don't even know to pick a separate vertical in there. So we want to make sure that we understand how that works. And now there's just a general lack of training, right? We don't typically operate a 3D environment in GIS, so we don't really understand what things like this. Anybody know what that is? Right there, what type of data that is? Well, it is a building footprint, but it's actually more than just the building footprint. It's the full building shape. So it's not just a footprint that's been extruded. It's called a multi-patch. How many of y'all have heard of multi-patch? Okay. How many of y'all have actually worked with and edited multi-patch? Okay, only one. That's not surprising. It's actually more than normal. So multi-patch is a true 3D data storage environment, and it is, you can create them in CAD, be it AutoCAD or MicroStation. You can create them in ArcGIS Pro, in ArcScene, in ArcGlobe. You can create it in QGIS, and it's a true 3D. You're drawing it in X, Y, and Z. And it's called a patch because each facet of the shape is a patch, right? It can be treated somewhat as a separate. Think of it kind of like a multi-part feature, right? So I can do some edits to this. I can pull it out. I can raise it up. And then automatically the things connected to it will respond. So if I raise this edge of this building up, then this connecting patch behind it is going to raise and stay connected, right? As well as the height of this side of this patch will go with it. So it's an interesting, it's a very different editing routine, trying to get in there and being able to say cut out. Say you've got a portico or something here you need to cut out, being able to cut that out and push that in or out as you need to, because it's acting as a solid in essence. So again, most people don't know what this is, and even if you do know what it is, most people have never even tried to edit them. And I'll be honest, I've just started trying to figure out how the best way to do it is. I can fiddle my way through some edits on them, but I'm certainly not proficient at it. But this is something that, again, talking about Esri environment, with ArcPro, you'll be able to edit these with a native product. You don't have to have the extension do that. You can create some of these going on. Being able to do things like this, a viewshed analysis capability. Most people don't know how to, or have not done those kinds of analysis, but as we're looking more and more into the 3D realm, that's going to be something, especially with planning in urban areas. What if I build this new building, what does that do to the surrounding other buildings? Is it going to block sun? If I've got a new building coming in here and I've got solar panels over here, or one of the new green roof initiative type things, and is that building going to block the sunlight to that? That impacts that owner, that other stuff going on. So we're going to have to start looking at those things more closely. The other thing we've got coming in, I don't know how much this has happened in North Carolina, but I know in Atlanta, in New York, Chicago, and all that, we're getting 3D parcels. And you're thinking, 3D parcels, what was that? Well, what's happening is they're trying to expand and build. Developers are actually coming in and they're building a new structure next to an existing structure. And the existing structure may only be 5 stories tall. And they're capable of going 20 stories with a new building. So they'll go, 5-story building next to me. They could go 20 stories, but they're not. I'm going to buy the air rights above that existing parcel. And they'll buy the air rights above that existing parcel and actually build a cantilevered building so it's like an inverted L. So now they've got extra office space and stuff they can sell. Or condos, or whatever it is. So now they've bought that, so it literally is a 3D parcel, because they actually own the area above the existing parcel. And that's a whole new challenge. It's one thing when we're dealing with condos, right? And they're all stacked on the same parent piece of land. Now we've got one that comes across and over, and it's not a true overlap because it's above what's on the ground. So if we're getting into those things, we definitely have to be able to go into 3D and know how to map those things and track them. So it's kind of neat when we see that kind of stuff happening. So if we're going to do this, how do we store the data? What do we put it in? Well, we can have Z-enabled geometry. We can have our points, lines, and polygons where they're Z-enabled. So that they're not just storing the X and the Y, but they're storing the Z. I already mentioned multi-patch. As we see here, we can do multi-patch structures, which automatically do that. We can have things, if we're looking at ground surfaces, because usually with all of this stuff at the base level, we've got to have something that represents the ground. So we can have things like tens. That's another vector format. Triangulated irregular network. Also something called a terrain, which is replacing the 10 slowly in there. Of course, LiDAR data. We pull in point clouds and we have our DEM. So all of these are different types of 3D data that we can work with. But even then, most of our 2D data we can extrude out as well. So if we're trying to choose where to store that, all of the CAD formats, DWG, DXF, and DGN are automatically Z-enabled. So they are always storing X, Y, and Z. Now the question is whether somebody's actually taking the time to put the Z in. So if you're an ARC user or a QGIS user and you bring in these CAD files, if you open the attribute table, you will see the shape field listed as point Z, polyline Z, polygon Z, okay? Because it's automatically Z-enabled. But you have to verify. If you bring it into a 3D scene and you see it, your data, if you have a ground surface elevation, your data's up here and it's suddenly down here below that, that means it's Z is 0, right? Which means it's not populated. So don't think that just because you pull in a CAD file and it says it's Z-enabled that it is truly Z-enabled. There. How can you tell if a shape file, because a shape file can be Z-enabled, how can you tell if a shape file has been Z-enabled? Anybody? Well, there's a couple ways. You can go to the properties of the shapefile, and there on the general tab of the probably will tell you, you'll have a checkbox, Z-enabled. Another way is if you just open the attribute table and you look at the shape field, again, it'll say point Z, polyline Z, or polygon Z if it's Z-enabled. And the same is true of geodatabase feature class, right? So for those to store Z values, true Z values, then you have to make sure they're Z-enabled. And you can either do that when you initially create the feature class or shapefile, or later there's geoprocessing tools that will allow you to do that. If you have, in Esri's world, the 3D Analyst extension, there's tools that will convert a 2D feature class shapefile into a Z-enabled one. So we can do that. KMZ, KMLs are automatically also Z-enabled. So they can automatically store 3D data. So those coming out of Google Earth, Google Maps, and whatnot. And then most of your databases, your SQL servers, Oracles, Postgres SQLs, all of those are spatially enabled nowadays, and you can, again, enable Z capabilities within those, depending on the admin capability of that. So you have a lot of choices nowadays on where to store Z data, or have different formats to use, depending on what your organization's using and how to do it. And it's not overly difficult. So how do you get your data in there to 3D? If this is what you want to do, right? Well, make sure when you're going out collecting new data that you're doing it right, right? That you're putting the antenna on the pole, that you assign the correct vertical datum, that you're occupying the point, making sure you're getting good quality satellite. Just make sure you're doing it right there. If you've got any existing data, convert it into one that supports 3D. So you can begin that process of adding that information to it, because you can very easily go in with geoprocessing tools, convert it to 3D, and then use things like the elevation model surface you have assigned to then at least apply a basic ground surface elevation to all of your features. Then you can use tools to extrude it up in the case of building footprints, right? The other thing that's really key here is that you've got to have a good ground surface, because that's kind of the canvas that all of your scenes, that's what we call a 3D map, is a scene, is built on. Right? Do you have something good, or are you going to be relying on the Esri terrain model, which is But yeah, if you've gone out and been able to get your own DEM or TIN or terrain, bring those in, then that's going to make everything a whole lot better with that. And of course, get your staff trained. I mean, make sure they understand how to work in 3D, how to edit those multi-patch features, or how they can even edit the z-values in the traditional stuff. And it's not hard. It's really, in most cases, it's just part of a window where you have the X and Y coordinates. You can also automatically have it assign the Z based on the ground model you're using. So it's just a matter of getting comfortable with it, not being scared. And I think that's part of the hardest thing, is we get scared because it's new. We don't like change. We get nervous with new. So we want to make sure we get them all trained up on that. So kept it kind of short and sweet here. Any questions about 3D, getting your data into it, what we can do with it? Yes, no, maybe. Okay. Yes? So the question is, do you need 3D analyst in ARC if you want to work with 3D data? It really depends on what you mean by work with. No, you don't. You can bring in 3D enabled data into, say, ArcMap and do things with it. You can't visualize it in 3D, but you can still bring it in as a normal layer. You may not be able to edit it without 3D analyst. I'm trying to remember with ArcMap. Now with ArcPro, there's no limit. You can bring in 3D data, visualize it in 3D. You can even edit it in 3D without the 3D Analyst extension. Yes, yes. What you can't do is things like the viewshed analysis. That requires the 3D Analyst extension. So some of those analysis, 3D analysis tools, doing a 3D buffer, that kind of stuff, still requires the 3D Analyst extension. But yeah, just from ArcPro's perspective, visualizing it, printing maps, querying it, editing it, creating it, you don't have to have an extension. So that's one of the benefits ArcPro brings to the table. So, good question. Any other questions? Okay. Well, hope you've enjoyed it, learned a thing or two. And if you have other questions come up, I'm here all week. I'll be doing a Migrating to ArcPro session Friday morning. So if you have any ArcPro questions, make sure you attend that. Because I literally wrote the book on ArcPro. Actually wrote 2 books on ArcPro now. Anyway, so have a great conference, and we'll see you around.